Okay, so today what we're going to do is we're going to solve absolute value equations, quadratic absolute value equations. So yesterday you got the rule in the linear equations that we were solving that if we have the absolute value of x equals c, that implies that either x equals c or x equals negative c. So we're going to do the same thing when we solve these equations today, and remember that we're going to have to check for extraneous solutions again. We're going to have to check our work. So, what I'm going to do is I'm going to take all of the polynomial that's inside this absolute value equation, and I am going to make two separate equations. One where the quadratic is equal to a positive 1, and another where the quadratic is equal to negative 1. So I'm going to go about solving both of these equations. And the first thing I'd like to do is put them in standard form. Well, let's just concentrate on this quadratic equation on the left. After I have a solution for that, we will take a look at the equation on the right. So I'm going to put this in standard form. I'm going to set it equal to 0. I have to subtract 1 from both sides. So negative 1 and negative 1 is negative 2. All right, it'd be really nice if this was factorable. That would make it a lot easier. So let's think about that. A times c is negative 6. If I look for factors of negative 6 whose sum is positive 6, and I don't think that that's going to happen. I don't think I'm going to be lucky enough. 2 and 3, 6 and 1. I can't seem to get that to add to positive 6. I'm not going to be able to, or it's going to be very inconvenient to solve this by completing the square, because if I divide everything through by 3, this c term is going to create a fraction. So I think the easiest way to solve this is going to be to do the quadratic formula. So I'm going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to simplify the stuff underneath the radical. So 6 squared is 36. Negative 4 times 3 is negative 12. Times negative 2 is positive 24. And the denominator, 2 times 3 is 6. 36 plus 24 is 60. And the radical here can be simplified because 4 is a perfect square. That is a factor of 60. So I'm going to break that down into radical 4, radical 15. Square root of 4 is 2. And then I can simplify that further. This fraction has 3 coefficients that are all divisible by 2. The GCF of 6, 2, and 6 is 2. So the simplest form of this fraction would be to take a 2 out of each of those things outside the radical. Negative 6 divided by 2 is negative 3, positive and negative. 2 divided by 2 is 1, so this will become 1 radical 15, and 6 divided by 2 is 3. So here what I have is 2 separate solutions. Remember, this plus and minus refers to 2 different possibilities. So one of them is going to be x equals negative 3 plus radical 15, all over 3. And another solution will be x equals negative 3 minus 15 all over 3. Okay, so here are two possible solutions. Now, when I go back and take a look at the second equation that we created when we took it out of the absolute value, I've got the possibility of another two solutions here. So again, I want to put this in standard form. I want to get the right-hand side equal to 0. So I'm going to add 1 to both sides. Negative 1 plus 1 is 0, so on the left, that constant term cancels out. And then this problem is going to be a lot easier on the right because this is factorable. There's a GCF of 3x. So let's divide 3x out of those two terms. 3x to the second divided by 3x is x. 6x divided by 3x is 2. I can set both of those factors equal to 0. And solve both equations. Okay, so I've got 4 possible solutions. What I want to do now is check for extraneous solutions. So I'm going to move over to a new sheet of paper. I'm going to just do a little bit of work and use a calculator to check to see if they are truly solutions. So we start again with the original equation that was given, the absolute value of 3x squared plus 6x minus 1 equals 1. All right, so if we were to plug in our 4 possible solutions inside the left-hand side, take the absolute value, it should equal to positive 1, and then we'll know that that solution was true. So here I'm going to start with x equals negative 3 plus radical 15 all over 3. Now this is a monstrous irrational